Hi, we're going to be doing 2017, number 4 from the AB Calculus AB exam, free response. This is a no calculator question, so let's get to it. So at time t equals 0, we have a boiled potato taken from a pot that's left to cool in the kitchen. The initial temperature is 91 degrees at time t equals 0. So that's initial condition, which they also mentioned down here again. And the internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. The internal temperature of the potato in t minutes can be modeled by this function h that satisfies the differential equation, this right here. Okay, so part A, they ask you to write the equation of the line tangent to the graph of h at t equals 0. And we're going to use that to approximate the internal temperature of the potato at time t equals 3. So we're going to approximate h. So we want to know what h equals at time t equals 3. And we're going to use the tangent line equation. So I'm going to try to utilize all space so I don't have to scroll up and down so much. So for a tangent line equation, we need the slope, which is equal to h prime of t, and we're going to evaluate that at t equals 0. And we need a point on h, and they gave us that here. Okay, because that's where it's going to be tangent. All right, so for the slope of h is equal to dh dt, and we're going to evaluate that at h equals 91. I'm not evaluating at t equals 0 because if you notice there's no value for t to plug in. So I have negative 1/4 times 91 minus 27. I'm literally using this equation right here. Okay, so we end up with negative 1/4 times 64, which ends up giving you negative 16. So now I have the slope. So my tangent line equation is going to be h minus 91 is equal to negative 16 times t minus 0. Okay, I'm just doing y minus y sub 1 equals m times x minus x sub 1. Okay, and so now I'm supposed to use this equation to approximate the internal temperature of the potato time t equals 3. So I'm going to plug in 3 for t and solve for h. So I have h minus 91 is equal to negative 16 times 3 minus 0. And we end up with h minus 91 is equal to negative 48. And then h is equal to negative 48 plus 91, which ends up being 43 degrees Celsius. Notice I put the units because the problem does have units. All right, so we have our tangent line equation, which you can leave like this, and we have our approximation. All right, moving on to part B. Basically this means the second derivative of h to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. So whenever they ask this, whether it's an underestimate or an overestimate, and we're using the second derivative, the purpose of the second derivative is to tell you about the concavity. Okay, so for part B, if h double prime is greater than 0, that implies that h is concave up. Okay, which would look something like this. Whichever side, it really doesn't matter. Okay, and if h double prime is negative, then that implies that h is concave down, which looks like this. And remember, our tangent line is approximating the value on the curve. This is my curve. Either this is my curve or this is my curve. So it doesn't matter where I draw my tangent line. Anywhere I draw the tangent line, if it's concave up, this would mean that if my tangent line is below, that means my tangent line has to be below, which implies it is an under approximation. Okay, and then here, if I draw my tangent line, any possible tangent line, anywhere on that curve, when it's concave down, that implies that our tangent line is above the curve, which implies that it is an over approximation when we evaluated the tangent line at 3. Okay, so let's figure out which one this is. Okay, so we're going to have to find the second derivative of this. All right, so I'm going to take the derivative with respect to t of dh dt. Okay, and I'm going to take the derivative of both sides. Okay, and what I end up with over here for d squared h over dt squared, I mean, you can write h double prime if it makes you feel uncomfortable, is we're going to have negative 1/4. And then I have to take the derivative, because this is just a coefficient, and I have to take the derivative of this and this. And the derivative of h is going to be dh dt. I could put a 1 there if I want, but it's redundant. And then the derivative of negative 27 is nothing. It's 0. So that's my second derivative. And now I'm going to evaluate this at time t equals 3. That's what this bar means. Evaluate it at t equals 3. Okay, so if I want to evaluate this at t equals 3, well, then I have to figure out what dh dt is at t equals 3. Okay, so if I evaluate dh dt at t equals 3, we end up with when we evaluate this, we have negative 1/4 times h minus 27, which there's nothing to plug in for t, and I don't have the h. Okay, so what I'm going to do is I'm going to put this in here, and I have that the second derivative for h, when I evaluate that at t equals 3, is negative 1/4 times negative 1/4 times h minus 27, which simplifies to 1/16 times h minus 27. So if you recall, up here in the problem, it said that the internal temperature of the potato is always greater than 27 degrees Celsius. So at time t equals 3, this h value has to be greater than 27. So if I just do an analysis of what the signage would be, well, 1/16 is always positive. And if this number for h is always going to be over 27, this is positive. So that means that this is greater than 0. H double prime is always positive. Okay, so then if h double prime is always positive, then that means that h is concave up. Okay, so if it's concave up, then we have this scenario right here, which means that is going to be an under approximation or an underestimate. Okay, so now we just need to say that. Okay, and they didn't ask you to justify, so I'm not going to offer any more information. So the internal temperature at time t equals 3 is an underestimate. Okay, and that's it for part B. All right, I didn't ask you to justify, but if I had to justify, I would say because h double prime of t will always be greater than 0, since the temperature h is always going to be greater than 27, meaning that it's going to be an under approximation. Okay, so for part C, for t less than or equal to 10, for t less than 10, an alternate model for the, let me just underline that, for the internal temperature of the potato at time t minutes is the function g that satisfies this differential equation, where g of t is measured in degrees Celsius and g of 0 is 91. Okay, so we have an initial condition. Find expression for g of t based on this model was the internal temperature of the potato at time t equals 3. They're really obsessed with the temperature of this potato. Well, anyway, so this is, we're going to have to do separation of variables here. So they want you to come up with the original function and then use that function to evaluate the internal temperature of the potato at time t equals 3. Okay, so we've been down this road before, so we're going to integrate. Okay, so part D, I have dg dt is equal to negative g minus 27 to the 2/3, and I'm going to separate my variables. Okay, so I'm going to cross multiply, and I have negative g minus 27 to the 2/3 dt is equal to dg. I need all my g stuff on one side, so I'm going to leave the negative over here with the dt, and over here I have my dg over g minus 27 to the 2/3. And now I'm going to integrate both sides. Okay, so I separated my variables. Okay, and now I'm going to integrate. Okay, so over here on the left side, I have negative t plus c, and on the right side, I have, if I'm like, I don't know what to do. Okay, remember, this is the same thing. This is the same as writing dg, actually, let me write it this way, g minus 27 to the negative 2/3 dg. Okay, it's the same thing. So if you're like, I don't know if I should use u sub, we'll try u sub. If I set u equal to g minus 27 and I take the derivative of that, I would just have dg. So nothing really happened. Actually, I should put that as a capital G. So nothing really happened. There's nothing that I really need to cancel. So I can literally just do reverse power rule. Okay, so I have g minus 27, and I add 1 to that, which would be 1/3, and then you have to divide it by that same exponent. And if I divide this by 1/3, I end up with, let me just fix that. Okay, g minus 27. Okay, so now I'm going to use my initial condition, which was that we have that g of 0 is equal to 91. I got to wrap up this question. All right, so I have negative 0 plus c is equal to 3 times 91 minus 27, and that ends up giving me that c is equal to 12. So now for my equation, I have 3 times the quantity g minus 27 is equal to negative t plus 12, or 12 minus t. So now I just have to get g by itself. So I have negative t plus 12 is equal to 3 g, oops, that's to the 1/3. So let me just fix that. So I'm going to divide. So I have negative t plus 12 over 3 is equal to g minus 27, essentially the cube root. And then I'm going to cube both sides. Cube, cube, and I have negative t plus 12 over 3 is equal to g minus 27. So g is equal to negative t plus 12 over 3 cubed plus 27, and then they want you to evaluate that at t is equal to 3, and this is for values from 0 to 10 because that constraint was given in the problem. So now I just need to find g of 3. So I just do negative 3 plus 12 over 3 cubed plus 27, and if you crunch that out, you end up with 9 over 3 cubed plus 27, which is equal to 3 cubed plus 27, which is 27 plus 27, which is 54 degrees Celsius. Done.